In June 2016, the MV Benita, a bulk carrier sailing under the Liberian flag, encountered a grave maritime incident as it ran aground off the idyllic coast of Mauritius. The vessel, en route from India to South Africa, found itself stranded on the coastal reef due to a combination of navigational errors, adverse weather conditions, and potential technical malfunctions. This grounding precipitated an urgent response from maritime authorities, environmental agencies, and a consortium of international salvage experts, as the vessel's precarious situation posed an imminent threat of oil spills and environmental degradation in the ecologically sensitive marine areas surrounding Mauritius. The salvage operation commenced with a meticulous assessment of the vessel's condition, addressing both immediate environmental concerns and the complex engineering challenges posed by the grounding. The foremost priority was to tackle the potential environmental catastrophe resulting from fuel and oil leakage. Specialized teams swiftly devised and implemented strategies to remove the remaining fuel and oil on board the MV Benita. This involved the use of oil skimmers, containment booms, and absorbent materials to minimize the spread of pollutants in the pristine waters surrounding the vessel. Simultaneously, efforts were directed towards stabilizing the MV Benita to prevent further environmental damage. The vessel's precarious position on the reef necessitated a comprehensive engineering approach. Salvage experts, naval architects, and marine engineers collaborated to devise a stabilization plan that would mitigate the risk of structural damage, oil spills, and potential exacerbation of the environmental impact. One of the primary challenges faced during the salvage operations was the precarious position of the vessel on the reef. The grounded ship's susceptibility to shifting, tilting, or further embedment in the reef demanded a nuanced and carefully orchestrated approach. Salvers strategically deployed a combination of tugboats, floating cranes, and dynamic positioning vessels to mitigate the risk of further grounding while facilitating the subsequent salvage phases. The collaborative efforts of authorities in Mauritius and international rescue experts played a pivotal role in orchestrating a comprehensive salvage plan. Coordination centers were established to streamline communication, ensuring that each phase of the operation was executed seamlessly. Environmental agencies collaborated closely with salvage teams to align strategies for pollution control, containment, and mitigation. Hydrographic and meteorological considerations were integral to the salvage planning process. Continuous monitoring of tidal patterns, wave dynamics, and sea conditions informed the timing of critical salvage operations. Salvage windows were meticulously chosen to coincide with favorable weather conditions, minimizing risks and optimizing the efficiency of the operation. The reflotation process demanded a delicate balance between applying sufficient force to dislodge the vessel from the reef and avoiding excessive stress that could compromise the structural integrity of the MV Benita. Salvage teams, in collaboration with naval architects, employed a combination of towage forces and controlled tension to effect a gradual shift in the vessel's position. This methodical approach leveraged the buoyancy of the ship, harnessing tidal dynamics to assist in the reflotation process. Underwater cutting tools were employed to address potential impediments, such as entangled debris and grounding-induced damage to the vessel's structure. Divers played a crucial role in inspecting and clearing obstacles, ensuring the smooth progression of the salvage operation. The careful removal of underwater hindrances allowed for the progressive dislodgement of the MV Benita from its precarious grounding. Throughout the salvage operation, safety protocols were paramount. Contingency plans were in place to address unforeseen complications, and regular safety briefings ensured that salvage personnel were equipped to handle the dynamic challenges of the operation. Close coordination with local authorities and maritime agencies facilitated the swift deployment of resources in response to evolving circumstances. As the MV Benita was gradually refloated and towed to deeper waters, the vessel's seaworthiness became a focal point of evaluation. Comprehensive inspections were conducted to assess the integrity of the hull, propulsion systems, and navigation equipment. The vessel's transit to a designated safe anchorage allowed for further assessments before being cleared for onward navigation. Post-salvage activities included an extensive environmental impact assessment and remediation efforts. Shoreline cleanup operations were initiated to address residual oil deposits, and ongoing monitoring initiatives tracked the recovery of marine ecosystems. Lessons learned from the MV Benita salvage informed best practices in maritime safety, navigational risk management, and environmental response. In conclusion, the stranding and salvage of the MV Benita off the coast of Mauritius in June 2016 epitomized the intricate challenges inherent in maritime emergency response. Navigational complexities, environmental considerations, and engineering expertise converged in a coordinated effort to mitigate risks, protect ecosystems, and salvage the vessel. The incident underscored the critical importance of interdisciplinary collaboration, contingency planning, and adaptability in safeguarding both maritime assets and the delicate balance of coastal environments. The successful salvage of the MV Benita stands as a testament to the resilience and expertise of those involved in maritime emergency response. In the realm of military operations, the utilization of diverse vehicular assets, ranging from robust tanks and tactical trucks to versatile benzs vehicles, is essential for maneuverability, logistics, and strategic mobility. However, the operational landscape often thrusts these formidable machines into challenging and unpredictable terrains, where forest roads, laden with slippery mud and treacherous conditions, become formidable adversaries. Military vehicles, equipped with specialized off-road capabilities, confront the intricate web of dense forests where the amalgamation of mud, uneven terrain, and obscured pathways tests both the mettle of the vehicles and the acumen of their operators. In the theater of operations, heavy military vehicles navigate through these precarious forest roads, encountering a landscape that demands not only raw power, but also finesse in maneuvering. Tanks, designed for rugged terrains, face the dual challenge of traversing through thick mud and maintaining tactical readiness. Their caterpillar tracks, engineered for traction, grapple with the slippery surface, making every movement a calculated effort. The weight distribution and suspension systems of these tanks become critical, ensuring stability and preventing slippage in the muddy morass. Tactical trucks, the logistical backbone of military operations, bear the burden of transporting personnel, supplies, and equipment through the labyrinthine forest pathways. These trucks, often equipped with all-wheel drive capabilities and reinforced suspension systems, navigate the intricate network of muddy roads, overcoming obstacles that threaten to impede their progress. The challenge lies not only in traversing through the mud, but also in ensuring the safe transport of critical assets without compromising their integrity. Benzs vehicles, recognized for their versatility and adaptability, contribute to the mobility of military units in diverse terrains, including the challenging forest environments. Whether configured for troop transport or serving as reconnaissance platforms, These vehicles demonstrate agility and nimbleness on muddy forest roads. Advanced traction control systems and robust chassis design empower these benzs vehicles to maintain operational effectiveness in the face of slippery conditions. The inherent danger of forest roads is amplified when considering the weight and dimensions of heavy military vehicles. The potential for slippage, tipping, or entrenchment in the mud poses risks to both personnel and equipment. Therefore, the operators of these vehicles play a pivotal role, utilizing their training and expertise to navigate through the hazardous forest terrain with precision. Skillful application of throttle control, steering input, and judicious use of braking becomes second nature to these operators as they negotiate the challenging conditions. The integration of technology into military vehicles further enhances their performance on slippery and muddy forest roads. Advanced traction control systems, differential locks, and adaptive suspension mechanisms work in concert to optimize grip and stability. In challenging terrains, these technological enhancements enable military vehicles to maintain momentum and overcome obstacles that would otherwise impede progress. While military vehicles are engineered to confront such adversities, the forest environment introduces an element of unpredictability. Concealed obstacles, such as tree roots, rocks, or sudden changes in terrain elevation, pose additional challenges. The risk of vehicles becoming bogged down or sustaining damage from hidden impediments underscores the need for vigilance and strategic planning during forest operations. In the face of these challenges, military units engage in meticulous route reconnaissance and planning. The selection of viable pathways through the forest involves considerations of topography, soil composition, and potential obstacles. Engineers and specialized reconnaissance teams play a crucial role in identifying safe routes and assessing the suitability of the terrain for the passage of heavy military vehicles. In instances where vehicles succumb to the challenges of muddy forest roads, recovery operations become a critical facet of military logistics. Specialized recovery vehicles, equipped with powerful winches, hoists, and towing capabilities, are deployed to extricate immobilized assets. The intricacies of recovery operations demand a comprehensive understanding of vehicle dynamics, terrain conditions, and the judicious application of recovery equipment. The deployment of heavy military vehicles in forested terrains is not solely confined to maneuvering through the mud. It extends to the strategic positioning and operational effectiveness of military units. Forests, often characterized by limited visibility and restricted lines of sight, necessitate a balance between mobility and tactical considerations. Vehicles must be agile enough to respond to dynamic scenarios, yet robust enough to endure the challenges posed by the forest environment. In conclusion, the deployment of military vehicles, encompassing tanks, trucks, benzs vehicles, and heavy platforms on slippery, muddy, and dangerous forest roads, is a testament to the adaptability and resilience of military logistics and operations. The integration of advanced technology, strategic planning, and skilled operators ensures that these formidable machines can navigate through the complexities of forested terrains, fulfilling their roles in strategic mobility, reconnaissance, and tactical maneuvers. As military units continue to face diverse operational landscapes, the effectiveness of their vehicular assets on challenging forest roads remains a critical aspect of modern military readiness and versatility.